Geometry nodes are great for creating motion graphics, and I've been using them every day, replacing more and more of my old Cinema 4D workflows in Blender. I particularly like working with text. In my opinion, it is way cooler and better implemented in Blender. It's not perfect, but it's getting there. One rather boring inconvenience I guess you have also faced is extruding a profile along text curves. The Curve to Mesh node clones the profile on each guide curve point and orients it so its normal faces the curve tangent direction. This works great for curved splines, but with text, in our case, we notice that the width of the profile curve stays constant along the guide, and that makes it look wrong, especially at the sharp corners. Try it yourself, and you'll see that the profile is not parallel all along the guide curve. I've seen a couple of videos on YouTube that attempt to address this issue. A big shout out goes to Blender Bash and Maurizio Bella. Their solution may be mathematically correct, but I think there's a shorter and more straightforward way to achieve the same result. Let's get started. Start with a traditional node tree, a string to curve that will serve as a guide, a curve to mesh, and a quadrilateral curve as the profile. We will be working with curves, so make sure to realize the instances that the string to curve node returns. Also add a resample curve in evaluated mode. This converts all the curve interpolated points into real geometry. Instead of calculating ourselves the previous and next point vectors to figure out the angle for each control point, let Blender do the hard work for us. Currently all the splines are polygonal. Switch the spline type to Bezier. This way Blender automatically generates control point handles aiming at the previous and next spline points and stores them as an attribute. We can use these vectors for our following calculations. Call a curve handle positions node. Check the relative toggle. Normalize any of the output vectors. Add a dot product node and feed a curve tangent vector to the other input. The dot product projects one vector over the other and returns the length of the resulting projected vector. This video is aimed at artists, so I won't go too deep into details. Suffice to say that this result will help us calculate the right ratio to widen the profile curve at the guide control points. The Curve to Mesh node already orients the profile correctly along the guide curve facing the tangent direction, so we only need to scale this profile in the tangent plane. The dot product returns a ratio which is less than 1, as both input vectors are normalized, so they each have a length of 1. If we use this result to scale the profile, it will shrink. To find the growing ratio instead, we divide 1 by it. Now it represents the growing ratio for each profile based on the angle at each control point. Combine a new vector, feeding our result only to the x and y components. Leave the z value to 1. Now use a capture attribute node to make this vector available to all points that will derive from this geometry. That is, all the points that will be generated from the Curve to Mesh node. Frame this node and call it Scale Up. We will use this value to scale the profile, but for that we need a pivot point. Our text curve control points will serve as pivot. Insert another capture attribute node and store the position vectors of the curve points. Frame this node and call it Start. Now we have all the components we need to calculate the correct scaling of the profile points. Append a set position node after the Curve to Mesh. Subtract our current position from the start vectors. This will return a direction vector that points from the guide control point to each of our profile point positions. If we multiply this direction vector by the scale up vector, we get the scaled up direction vector for each profile point. But remember, this is just a direction vector, not a position in space. Add this to the start vector and feed this result to the position input of the setPosition node. To observe the difference, go back and insert a mix vector node before the scale-up capture attribute node. Set the vector B values to 1 and play with the mixing factor. See? This is the original profiles and this is our corrected result. The lines are parallel all along the text spline. Now go ahead, if you want, group these nodes and save them as an asset. I'm using text in my example, but this method works with any other polygonal shaped curve or 2D logo. You can also use any curve shape as a profile, not just a rectangle, triangle or star. You can even use the object where this geometry node modifier is attached to draw a custom polygonal shape profile. In that case, remember to convert the mesh to curve before proceeding and feed it to the curve to mesh node. This is as far as the technical part goes. Now you can build any custom profile for your 3D text and logo animations or combine them with the filled and extruded text. Unleash your creativity. Another time, maybe I will even show you how to create some cool MoGraph piece. Let's call it a day, and remember, if you like the video, share the knowledge.